So you have a little foldable in front of you. You may cut it later, but right now, if you would just fold your edges into that middle line. So today we're talking about percent change and percent error. You're gonna see these things come up a lot as you move through middle school and high school in your science classes. It's just a way to express when something changes, okay? So numerical values or numbers change, or if somebody is talking about a mistake that they might make, that's where percent error is going to come into play. So one of the examples I gave last hour is when you get older and you get a job, hopefully each year or couple of years or every so often you will get a raise. And they usually will say that everybody gets a 5% raise or everybody gets a 7% raise, because if you're the person who makes the most in the company or the least in the company, you're still going to get the same percent change, but the amount that you're going to get is a little bit different based on how much money you make, okay? So percent change and percent error, just ways to express change or errors in numbers as a percent, okay? So go ahead and open up this left-hand side. Both of them, we're going to use a formula that is a fraction. And then we're going to turn that fraction into a percent. You already know how to turn a fraction into a percent. We've practiced that. So really, the only thing that's new here is looking at the problem and being able to fill out the numerator and denominator of the fraction based on the problem. Okay? So percent change, we're going to use the formula change over, or as we know, a fraction bar means divide, divided by the original. Okay, so that might be the original price, that might be the original score on a test, but it's change over original, or change divided by original. Okay? Original means where does it start? All right? Then we have percent error, which we're going to say is the difference over the actual. So go ahead and fill those four in. So we've got change over original and difference over actual. Okay? Then we're going to take those fractions that we get and we're going to turn them into percents. All right. So our first example, most of these types of problems are going to be situations or word problems, okay? Because we have to know where we start and where we end and all those things. So the first scenario we have is Charlie. Charlie received a 92 on his first test. I'm going to use Spanish class because that seems to be a hot topic in my Eagle Hour all of the time. So Charlie goes to Spanish class and he gets a 92 on his first test and he feels very arrogant, which means he's like, I'm really good at this, so I'm not going to study for the next test. The next test, he does not study. He goes in and he gets a 60. So we're going to talk about that as a percent change, okay? First, I want you guys to underline the word decrease because that's an important part of this. When you do your assignment today, it's going to say, is this an increase or a decrease? Obviously, he went from a 92 to a 60, so that's a decrease, okay? So we're going to use our little formula we wrote up here, percent change, and we're going to put change on top and original, the original number, on bottom. Change over original. Okay? So the first thing we need to do is figure out how much did he change? How much did his score decrease? It went from a 92 to a 60. So it decreased by how many points? I hear it whispered. Very good. 32. Those of you who got that, you just did a subtraction problem, right? 92 minus 60. Okay? 32. Then we put the original number on bottom. So his original score was a 92. Okay, change over original. 32 is our change. 92 was our original score. Now, if you remember from 2 weeks ago, we know how to turn a fraction into a percent. The fraction bar means we're going to do what operation? Divide, okay? So pick up your calculators and you're going to type in 32 divided by 92. It's very important that you put your numerator or top number in first. 32 divided by 92. Okay, and you're going to get a big, long decimal. Now, we're going to end up turning this decimal into a percent, so I would like 3 digits, okay? So I want the thousandths place. So we have 3, 4, 7, but since the next number is an 8, that 7 is going to bump up to an 8, right? 5 or above, give it a shove. So I'm going to write down here 0.348. That's the decimal. So I just took numerator divided by denominator. Then, if you remember from last week or the week before, we're going to take that number times 100 in order to get a percent. Yes. Because this 8 right here, to the right of it, makes us round this 7 up. If this was a 2 or a 3, we would keep it as a 7. If it was below 5, we would keep it as a 7. Okay? Now, I have 2 choices when multiplying by 100. I can either just keep the number that I have on my calculator and hit times 100, 34.8, because we're going to round it still. Or I can take my decimal point and move it 2 places to the right. So his score changed by 34.8%. So change over original, then we turn that fraction that we get into a percent. Okay, let's go to our second example. This time we have Tanya, who is a shopper. She goes to the store and she decided there was a shirt that she wanted, but she decided not to buy it because it was $35. I agree with Tanya, that's a little expensive. Okay, so she says, I'm going to wait to see if it's on sale or if it goes on sale, right? Things always go on sale. So I'm going to go back. She goes back to the store to see if it's on sale, and it's now $40. Okay, so clearly that did not go on sale. The price increased. So we're going to find out what percent did it increase by. Our change goes on the top, and our original number goes on the bottom. Okay, so how much did the price of the shirt change? You can show me with your hands. How much did the price of the shirt change? Right, $5. It went from 35 to 40. What was the original price of the shirt the first time she went to look at it? 35. Okay, so you have to read the problems carefully. You can't just choose the greater number because this is a percent increase. So it went up, which means we're actually going to start with the original is smaller. All right, to change that fraction to a decimal, we take the numerator divided by the denominator. Do this with me on your calculator so you get used to it, please. 5 divided by 35, okay, 0.1428. So that 8's going to make our 2 turn into a 3. If you're getting stuck on the rounding today, make sure you're asking because that's something that will continue to come up. So there's my decimal, but I need to turn my decimal to a percent by multiplying by 100. So I'm just going to move that decimal point 2 places to the right to get 14.3%. So the price of the shirt increased by 14.3%. All right, now Martin is a scientist of sorts, and this is where we're going to see a percent error question. It's the exact same math, okay? It's just a different context, so we're gonna kind of look at the problem a little bit differently. So Martin estimated that there were 400 bees in a hive. Upon speaking with the beekeeper, he found out that there were actually 600 at any given time. Calculate the percent error. So they want to know, how wrong is Martin, right? How off is he with his estimate? So on the top, we looked over here, it says difference. So we're going to put the difference on the top. What's the difference between 400 and 600? It's a subtraction problem, just like what we did with percent change. Okay, so notice it's pretty much the same thing. The only thing that's different about this is we don't have an original or a new number. We just have an estimate and an actual. So we're going to put the actual on bottom. So difference on top, and then the actual on bottom. What's the actual number of bees? Okay. So notice how it's pretty much the same math. We just have to put actual instead of original on the bottom because we don't have an original. So again, we're going to turn that into a decimal and then a percent. So those of you who already have your calculators, awesome. We're going to put our numerator in first. We have one of those repeating decimals, but thankfully we know how to show that, hopefully. If I move my decimal point 2 places to the right or multiply by 100, I'm going to get 33.3%. And since I do have a repeating decimal, the more accurate we can be, or specific we can be, the better. So I'm going to put a bar above that 3 to show that it goes on and on and on and on. Okay? So we're going to put our change or our difference on top, our original amount or our actual, if it's a percent error, on the bottom. So now we have a fraction, and we're going to turn that fraction to a decimal by division, and then turn that decimal to a percent by multiplying by 100. Okay? So you're going to have an assignment today on big ideas. And I'm just going to quickly go over the expectation of that assignment. So on number 1, the question is something like the number starts with 12 and increases to 36. So here's the problem that you'll see on your computer. Here's what I expect on your paper. You're going to do the assignment on big ideas. But I want to make sure that you're actually putting the right numbers into your calculator. So the minimum that I expect is that you do the fraction on the paper. Okay? So the change from 12 to 36 would be 24. If you didn't know that by just looking at it, you could type it into your calculator as a subtraction problem. And then the original is 12. So this is what I expect to see for each problem. If you want to go further and show me the next step, you may. You're welcome. I just did number 1 for you. Okay? So this is what I expect, is at least the fraction, but you could show more work than that. When you get toward the end of the assignment, there's a few review questions like what we've been practicing as bell work. So just show your work like you would normally do. Okay? So big ideas assignment. You have about 13, I believe, questions. You're going to work on that till the end of the hour, and it is due tomorrow.